Hey everyone, welcome back. So today is the day two of our Generative AI course. So today we will be discussing about feature engineering. So why not ML algorithms? Why feature engineering? Because it's like a basic pre-processing steps that are required to perform ML algorithms efficiently. So let us suppose you have a data. Okay, okay. We need to pre-process it. Like the data is not pure, not perfect. Okay, we need to pre-process it. We need to pre-process it. So the pre-processing steps is known as feature engineering. So what is mean by feature? Feature is a row. Like when you have a CSV file, the row, the each row, sorry, the column, the each column is known as feature. Okay. So what we will be doing using this feature engineering techniques. So there will be many problems like there will be missing values. There is a numerous amount of invalid data. Maybe anything that is not perfect will be eliminating in this step. So when you see when you see data science, okay, there's a data science projects. 5% on data, sorry, 5% of data retrieval or data collection and 20% on model development and 70 to 80% of 70 to 70 feature engineering because it is that important topic. This is a very important topic for an data science who is pursuing his career in data science or any these are the basic steps we need to know to become an AI engineer or to excel in generative AI also because here we will be working on textual data like the basics of everything will be starting from here. Okay, the feature engineering is classified into four types. Okay, so feature engineering. Okay, feature engineering is classified into four types. First, first one is feature transformation. Feature transformation. Okay, what is mean by feature transformation? Let us suppose you have data like cat, dog, or some any elephant. So our model can't understand words. So it will be requiring numeric numbers. So we numeric items. So we need to convert this into numerical. I will giving cat as one, dog as two, and capital elephant as three. So this is known as feature transformation. Let us suppose another example is like uh, you have ratings. Okay, we'll be discussing rating. It is 100 out of 100. So when you multiply it with any large number, the multiplication will be like very large. So to eliminate this, we will be reducing it to 0 to 1. Okay. So 100 will be given as 1, 80 will be given as 0.8. So like this will be transforming the features. And second one is feature construction. Feature construction. Okay. What is mean by feature construction? So example, you have your date of birth. date of birth. Let us suppose that you are from 1990, 1990. So 7th April. Okay, this is 4. So we can transform, we can construct a new features like age using this. Using this, we can construct this. Okay, so this is known as feature construction. So the age will be like 35 years. Okay, 35 years. So this is known as feature construction. We will be discussing it more deeply in upcoming classes. So next, feature selection. Sorry, feature selection. So you don't need every feature, each and every feature to predict an next outcome. Let us suppose that there is student data. Okay, we need to predict this. Let us suppose we need to predict placement like is CTC using this college data. The features are is CGPA. Okay, is CGPA, is communication skills, is name, is name and address. Okay, so and the we need to predict is CTC. Okay, these are X values, these are Y. This is we need to predict Y values. So to predict CTC, we don't require name and address, right? We only require if a person has about 9.5 CGPA, then probably getting more CTC than a person who is with a 6.5 CGPA. Hypothetically, he is he have a good knowledge on some CS fundamentals, right? So this is the feature selection. So the last one is feature extraction. The last one is feature extraction. Okay, feature extraction. So let us suppose you have a data of 9 dimensions. Okay, probably this is also less. Let us suppose you have 90 dimensions. We need to when we are training a model, when we are model training, the time of model training, it will take more and more time because it need to evaluate 90 dimensions, right? So it more takes more time. It will taking more time. So to eliminate this, we'll be using some techniques like PCA. We'll be discussing this algorithm also. This will reduce the dimensionality of the features. Will reduce the 90 dimension to 3 or 4 dimensions without much loss of data in it. Like the features of the data set will be saved or like will be preserved while converting it from 90 dimension to 3 or 4 dimension. So this is the feature engineering. So we will be discussing now what is mean by in transformation also. Okay, okay. In transformation, there is another step, feature scaling. Feature scaling. Okay. This is known as feature scaling, the other word of. So we'll be discussing what is meant by feature scaling. So how we can implement it. Like we will also learn about the coding part also. So what is mean by okay standardization. 1 minute. I will be changing the okay. So feature scaling. Feature scaling. Feature scaling is categorized into two types. Okay. One is normalization One is normalization, one is standardization. Okay, we'll be discussing both in this video also. So, what is mean by normalization? What is mean by standardization? So, okay, in most of the cases, the feature scaling will be used after the pre-processing steps, after like eliminating the after missing values, after eliminating the missing values, or like imputing the missing values, or dimensional reduction, anything 3D dimensional reduction. After this, we'll be using the feature scaling. So, what is mean by feature scaling and what is mean by standardization? Okay, what is mean by feature scaling? Okay, let's take an example. So we are in a Domino's Pizza Hut. Okay, right? Domino's Pizza. Okay, we are at Domino's Pizza. So you have ordered it and you have completed your meal, and they asked for the review or feedback. Okay, feedback. Pizza feedback is out of 10. You can give 1 to 10 or 0 to 10. So, and the cleanliness is out of 100. You can give up to 0 to 100, right? Okay. So the when you calculate the total score, so when you calculate the total score, pizza plus clean is will be out of 110, right? So the score of the cleanliness will be overshadowed, like overshadowing the pizza, pizza rating. So we need to eliminate this kind of problems. So to eliminate this, we introduce feature scaling. So we'll be converting the cleanliness out of 100 to 10, or we'll be converting 10 to 100. Most of the cases we'll be converting into 10, because it will reduce the computations. Like if the number is smaller, then the computations will be small. So we're most probably using 100 will be reduced to 10, or both are reduced to 1. Okay. Now take example. Now take an example. I have given pizza rating as 7. Okay. And cleanliness rating as 80. So these will be reduced as 0 0.7 and 0 0.8. Okay. 0 0.7. Now the total score will be, so now the total score will be will be 1.5 out of 2, right? Now it is a better scaling, because the importance of pizza and the cleanliness are both are preserved. Okay, this is known as feature scaling. So then what is mean by normalization and standardization? Okay, let's discuss what is mean by normalization. Okay, we will be, from here only we will be discussing. So what is mean by standardization? What is mean by standardization? It has another name also, that is Z score. Okay, let us say take the same example, pizza and cleanliness. Okay, pizza. This is one feature, right? So I have around n number of rows. Okay, inputs like 8, 9, 3, 7, 5, 10, and so on up to n. So the after the standardization, pizza dash, what will the normalization will be doing? So this is x, right? Let's suppose this is x dash. Okay. Now x dash is equal to xi minus x bar by standard deviation. So what is xi? Xi is the current row value. This is known as mean. This is known as standard deviation. Okay. So let us suppose then the current value is 9. The average is 8. Let us suppose the standard deviation is 1. So it will be x bar equal to 1 here. In case of 8, 8 minus 8 by 1 equal to 0. In case of 7, 7 minus 8 by 1 equal to minus 1. Okay, you're understanding it, right? So the normalization after the we will be reducing these numbers to this using normal standardization. Sorry, standardization. Okay. So what is the role of standardization? Like so now I will be showcasing the coding part of the standardization. Okay. So just follow me and I will tell where you can get all this. So first we need to import the pandas library. So this is for data manipulation. And also some we need to plot because to show the accuracy or to show the diagrams. Okay. So we use matplot for this as PLT. Okay. And then we'll be using scikit-learn. Scikit-learn. Okay. This is scikit-learn. So in machine learning, we'll be going to use all these libraries from the scikit-learn. Like we can get random forest. Every ML algorithm can be found here, and it is the most important library when you are learning about machine learning. Okay, so there are many things in scikit-learn. Like they have some data sets, pre-defined data sets, which are available when we. So I'm taking a load like iris. So I'm taking iris dataset from the scikit-learn datasets. And also I need to showcase the standardization, right? So to import standardization, we must go to the scikit-learn pre-processing and import standard scalar. Okay. Yeah, it will be done. And data will be equal to load iris. Okay. So let's see how the data will be looking like. Okay, there is some problems. Sorry, there is a spelling mistakes. Okay, so we'll be loading the iris dataset data. So let us see how the data will be looking like. Data. Okay, so this is the data that we'll be looking. So I will be converting this into the data frame so we can look properly. So let us we have 4 columns here, 4 features here. So I'll be taking only one feature to showcase to make it as simple as that. Okay. Okay. Yeah. Then I will be storing it as and y equal to data dot target. Okay. So I don't need the entire data. I just need the one column, right? So this is every row and this defines the column. So I'll be taking all the rows, but I'll be taking only up to one row. Okay, right? So this will be processed. And the feature names are present in this. Feature names is equal to data dot feature names. One. Okay. So we'll be taking only one column, right? So we'll be taking only one feature. Okay. Yeah. So we got X value, Y value, and features. Okay. So we'll be converting this into the data frame. DF equal to, let's convert it to the data frame. So using the pandas library, we can convert it into data frame columns equal to, yeah, I think it will be converted and sure. Yeah, now it is converted into a data frame. So this is the data we have. This is the data we have in our data set, data frame. So we will be normalizing it, standardizing it using standard scalar. Okay. Okay. Let's start. So here I have shown you how we can convert the loaded data into a data frame. So now let's import a scalar that we have imported, that is standard scalar. Let's load the scalar. Okay, scalar. So we need to scale one, right? Only x we need to scale, and using that we can define the target fit transform. So fit fit is the most important word in the machine learning because it's like training the data. We can just model dot fit you and when we pass the arguments, when we pass the data as the arguments, then the model will be trained. So the fit means it's like a training process. Okay, in machine learning, in generative AI also, when we define what is fit, it is mean by training of data. Okay, so we have scaled it. Okay, let's see how the scaled data set look like. Okay, so you can see the first data, which is 5.1, is now converted into 0.9, and the second 4.9 now is converted into 0.1.14. Okay, so let's convert it into a data frame. Okay, I will convert it into a data frame scaled. Okay, df dot scale columns equal to, uh, we just need the feature name, right? Only one feature, so that is x, or it's, I think it's a sepal length, I guess. Sepal length. Okay, yeah, it is a sepal length. Okay, df. Okay, df scale. Now the data looks like this. So the entire data, the mean of the entire data is 0 now, and the standard deviation is 1. Okay, now we got it. So let's see the accuracy. Let's see the accuracy using this. I think because of only one feature, the accuracy won't change that much. Okay, so okay, let's see. Let's see the shape of the scaled data. So let's combine the data set. The concat. We can use the concat function to concat both the data frames. Okay. Now the data frames are df dot, just I'm taking the head. It means the top part is known as head. Scale dot head. Okay. When we pass head, the argument it will be taking is 5. So the first 5 will be displayed. Okay, this is the combine. Let's see how the combine. See, for this, you can see the values change. The standardized value is 0.9. Okay, now you got the point. Like we will be using the standard scalar. So we will be using the standard scalar to standardize the data. That's it. It's simple, just the two lines. Just we need to import this, and we need the data set, and using the scalar, standard scalar, we can just fit transform it and transform the entire data into standardized form. Same, the normalization thing also works say exactly same will be showing. Okay, so now you understood how this works. Let's see how the data looks. Okay, now I understood. Okay, we need a matplot to to showcase this data. 1 minute. And fixed size is, and this is the grid length, and you can just follow the matplot library, like website, to know about this more. Like it is the basic things that you can learn easily by seeing that, like what you can say, the website or interface. Just the basic things you can learn using this. Okay, so let's give the title. First, we need to tell that original original data. Okay, now let's plot the df. Okay, and legend. The legend will be df dot the column names. Okay, next, this is the original. Now we need to standard original, and we'll make it a standard. Okay, df dot scale. Okay, same environment, and this will need to show it, right. Df dot show. Okay, let's see how the data will be looking after the standards. Yeah, you can see that, right? The entire thing. You can see the difference. I think there is some issue here. Let's suppose I need to yeah, you can compare the exact every pattern is exactly same, but you can see the the range, it is from 0 to 8 and 0 to 140. Here you can see 0 minus 2 to 2. So the mean will be at here or somewhere like this, which is equal to 0. Now you understood how the standard scaling will be working, right? So it is the same. It won't compromise the patterns. It just standardize. It's scaled down the entire patterns into smaller sections, so we can use it for the later computations. Okay, so let's compare a model. Okay, uh, let us take k neighbors. I have told you about the k neighbors, right? I will be going to teach you about knn. So k nearest neighbors, and let's see the accuracy, how it will be giving on a non-scaled data and scaled data. So I think because we will be taking only one feature, right? So it won't deviate much, but there will be slight difference. I've already written the code. Let's see. So you can see the accuracy without scaling is 77.78, and accuracy with scaling is 80%. Okay, now I understood, right? So just the same thing. We'll be loading the data, and we'll be taking and train test split. We'll be discussing what is mean train test split. Like if there are 100 rows, we need some rows for training and some for testing, right? So the train test split that we'll be getting from the model selection. So what we will do, like 0 0.3, text size is 0 0.3. So out of 100, 30 records are used for test purpose and 70 records are used for training purpose. Okay. So the model with without standardization and a model with the standardization, and this is the visuals, and you can see the difference because we have used only two features, right? So when we work on larger data sets, the difference will be more. when you compare to this. There is around 2%. That's it. Because of the size size of the data set we are using. We are only using up to 150, right? You can see here only 150 rows are there. So when we go like when the data set size is like around 1,000, then the difference will be used. Like you can get up to 90% using scaling, like standardization, and 0%, not zero, some 70 to 75% without scaling. So this is the coding part of it. Now we'll be learning about the normalization. Okay, so now we have clarity on what is mean by standardization. So let us know what is mean by normalization also. Okay, so what is mean by normalization? So it is different from standardization, but does the similar thing. Like in standardization, 1 minute. Okay, in standardization, we reduce the features and the mean will be zero and standard deviation will be one, right? Now, in normalization, we don't change the shape, don't change the shape. We will preserve the shape of the data, but we will be shrinking it to the range of 0, comma 1. Okay. So let us suppose you have a data like this. Okay. And here it's up to 1,000 and here also 1,000. So we will be reducing the shape. The entire shape will be reduced. That's it. Here one, here one. The these and this is similar. Same. These and this is same. This and this is same. So this is known as normalization. So why we use a normalization? So first, what how this normalization technique will be used? So x of norm, okay, x of norm equal to x minus x of minimum, x of minimum by x max minus x min. Okay, what is mean by x norm, x norm? Okay, so let us take the example as pizza. Okay, the rating of the pizza will be from 10, 1 to some, and some n number of rows will be presented. So how we will normalize it? So normalization, pizza norm. So we'll be writing here pizza norm equal to 10 minus what will be the minimum? So somewhere there will be 0 also, right? So 0. What is maximum? 0. Okay, now you understand. So the normalization of the 10 is 1. So pizza norm here 1. So this is 1. Okay, now you understood, right? So let us take for 7. Pizza norm of 7 equal to 7 minus 0 by 10 by minus 0. That is 0.7. So this is converted to 0.7. So this is known as normalization. Simple. This is known as normalization. Why we use this normalization technique? So let us suppose you have a salary. Salary. There is a feature called salary. So this will be like 75,000, 125,000. So any random numbers. So these when we apply model training, when we get into the model training, the calculation becomes more and more complex. Understood? The more and more complex because when we uh, multiply 75,000 into 125,000, it will be giving some number, right? These big numbers when we come to, we need some big data structures are needed to store. So to eliminate this, when we calculate 1 into 2, the time taken will be lesser than the time taken to calculate this, right? So to eliminate this, we introduce normalization technique. These will be converted from 0 to 1 in the range of 0 to 1. That is known as normalization. Okay. So when some models like decision tree, decision tree, okay, decision tree, random forest don't need scaling. Scaling is not required. Okay, scaling is not required because we'll be discussing it when it comes to the model ML algorithms. Okay, where we need to use normalization and where we need to use standardization. Okay, so normalization will be used in some algorithms like KNN and neural networks also. Why KNN? So let me give you a small brief introduction about KNN. Okay, KNN algorithm. So how it will be calculated? So these are the points. So these are the points. So when a new data comes, okay, data is let us suppose 4 comma 5, 4 comma 5. So it will be 4, 5, and intersection point with this. So we will predict these data using the nearest neighbors. Okay, first neighbor gives 2, neighbor gives 3, third neighbor gives the data as 2, fourth as 5. So the data will be predicting data at 4 comma 5. Sorry, data at 4 comma 5 is 2 plus 3 plus 2 plus 5 by 4. Okay, understood, right? This is 12 by 4. This will be predicting it as 3. So data here, the prediction will be 3. This is known as KNN. So why we use normalization in KNN? Because normalization, we need to calculate the Euclidean distance right here to calculate this. So when we need to find the Euclidean distance to reduce the complexity of computations, we'll be using normalization to reduce the large amount of big data, big numbers to small integers. So we'll be using CNN. So where do we use standardization? Okay, standardization. So where we use standard in algorithms like logistic regression, hmm, PCA, support vector machines. So because these algorithms will perform better when the mean is zero, like understood right? When the mean is zero, these algorithms can perform much better. Like it will be giving more accuracy when you perform standardization. So this is the theory of the normalization. So now we'll be learning what is mean. We'll be coding it in the Google Colab. So let's go. Okay, now let us see how the coding part of the normalization look like. Similar to the standardization, we need to import the data set. That is from where we should import from scikit-learn dot datasets. Okay, we import the datasets from scikit-learn dot datasets. Import what we need to import. There are many numerous amount of datasets. You can go through the. You can see here. low digits, low simple sample images. So everything, many will be found here. So I just need the iris dataset for now. So we will be using more and more datasets on future. In future, we'll be using every more and more datasets. Okay, and for the pre-processing, so I need from pre-processing. Similarly, we imported the standard scalar from scikit-learn dot pre-processing. We'll be importing the normalization techniques from min-max scaling from same pre-processing because the feature engineering is nothing but pre-processing, right? So from scikit-learn dot pre-processing, we import the libraries that we use in feature engineering. Okay, so import min-max min-max scalar. Okay, and also yeah, that's it. These two are the things that we need for the coding part of the dataset. Okay, data equal to same load iris. So just code with me. Okay, so you can learn and code ML very fluently. Okay, data load data, and I will be change. I only require the data set, right? I only require one column because to showcase. I'm sorry, to showcase the simplicity. Okay, for the simplicity, I'm taking only two features of it, and yeah, let's and we need also feature names. Feature names equal to data dot feature names dot, and we'll be taking only two columns, right? So the features we required is only two. Okay, done. And original data set. Okay, I will be converting into I will be converting these into a data frame. So now X looks like this. I need to convert into a proper visual format, right? So df equal to df dot data frame. Okay, using data frame, I will be converting X into a data frame, and the column names are columns equal to feature names. Okay, now you got it right. So now you can see how df look like. See, this is how before the X is represented. Same 5.1, 3.5, and here 5.1, 3.5. Similarly, okay. You need to code. After watching the video, you need to code the same thing by yourself. So you can improve a lot. Okay. So let's next thing we have done is importing the scalar, right? Importing the library, importing the same similar thing. I'll be importing the library min-max scalar. Okay, sorry. So scalar equal to min-max scalar. Okay. So next normalized x norm. Okay, x norm. How we can normalize it? Using scalar dot fit transform. Okay, we are not training the data. We are just transforming the data. So we use fit transform. But training the data, we use fit. Okay, so we are just transforming the data from one form to other form. So we'll be transforming. We'll be using fit transform and x. Now a df norm. So just similarly, we need this code. Okay, for this, so here we need to replace now. Okay, and let's see how the data looks like. See, we can see the difference, right? Let's combine it. Let's combine and we can see easily. I have told how we can combine two data sets using concat. Okay, using concat, and we need data set df comma df dot norm. Let we will be concatenating everything. and axis equal to 1. df combined. You can see. So 3.1, uh, no such thing is greater than 1 and no number or no integer is less than 0 in these two rows. You can see sepal length, the normalized form, everything will be in form of in the range of 0 to 1 as we have discussed earlier. Here you can see 5.1 is converted into 0.5, 0.222. Okay, 4.9 is converted into 0. Everything. This is the coding part of the normalization. Just what you have done, just import the libraries, load the data set. Okay. First import the libraries, load the data set, and use the transform, load the data set. We have loaded the data set and use the normalization standardization and just see the output. Yeah, that's it. It's very simple. And yeah, this is the coding part of the normalization. Okay, so we have discussed what is mean by feature scaling. In that we will be having a normalization and regular normalization and standardization, right? So in the same feature transformation, we have encoding, encoding the categorical data. Okay, one minute. So encoding the categorical data. So what is mean by categorical data? What is mean by categorical data? So what is mean by categorical data? The data which is present in the textual form, data present in the textual form is known as categorical data. These are classified into two types. Okay, one is nominal form, nominal. One is ordinal. So what is meant by nominal? The nominal categorical data don't have any order, no order. So no order. Like examples, let us suppose a dog, cat, parrot. These don't have any order, right? So we can't assign this as one, this as two, and this as three. So this is known as nominal data. Ordinal data it contains order in it. Okay, like example, the grading system. Suppose we have got A, B, C. We can give E1, this as 2, and this as 3, right? This is known as the ordinal data. Okay, so for encoding the nominal data, we use to encode the ordinal data, we use ordinal encoding. To encode the nominal data, we use a nominal encoding or one-hot encoding, which we will be using. So, what is mean by ordinal? Ordinal encoding. Okay. So, what is mean by ordinal? So, I have explained it. Like ordinal encoding is encoding the data which have an order in it. Okay, which have an order in it is known as the ordinal data, ordinal encoding. So, so these are of two types, like label encoding, again, label encoding, and ordinal encoding. So, label encoding will be doing the same thing as ordinal encoding, but label encoding will be used in the target column. Let us suppose you have a row, you have a data. Okay, this is y, this is x. Okay, this some data is these are all x. Okay, so to convert these categorical data, which are in the ordinal form, we use ordinal encoding. We use ordinal encoding. So to convert these forms, let us suppose in the classification problems, we have the labels. To convert the labels, we use label encoding. Okay, understood, right? This is known as label encoding and ordinal encoding. So ordinal encoding will be doing the same thing. Okay, let's take an example to show what is meant by ordinal encoding. So ordinal encoding, okay, let us suppose we are in a we are doing some recommendation systems. Okay, recommendation systems of hotel. Let's suppose hotel. Okay, it consists of three categories. Okay, butter chicken, okay, butter chicken. It is of mild spiciness. Okay, next we have paneer tikka masala. This is of medium level of spiciness. Okay, and other is biryani. Biryani is of hot spicy, very hot. So we can give it as 0 and this is 1 and this is 2, right? So we can transform the, let us suppose a user one. User one has ordered around 20 mild and 2 biryanis, which is hot. And user 2 ordered 10 times biryani and 3 times paneer tikka masala. Okay. So using this data, we'll be predicting we'll be recommending the mild and medium spicy to user one and medium and hot to user two, right? Using this. So we will be transforming the data, the butters mild into 0, medium into 1, hot into 2. So using this, because AI, because AI can't understand text. Okay, so it only understands numbers. This is what it is. Okay, this is what ordinal encoding means. Okay, now I hope you understood it. So let us play into what is meant by nominal. Okay, in nominal, I have explained you what is meant by nominal. So a data which does not have any order in it, any meaning in it. It's just a text. Okay, let us suppose you have an example as colors. Okay, example blue, red, and green. Okay, these three don't have any relation, no relation, right? We can't use ordinal encoding. See, ordinal encoding. So to represent it, so we'll use one-hot encoding. One-hot encoding. So what is meant by one-hot encoding? It will be represented in the binary forms. Let us suppose red, green, blue. These are represented as, okay, these are represented as 0, 0, 1, 0, 1, 0, 1, 0, 0. Understood, right? So these are represented in the binary form, binary kind of look-alike. So if we assume red, then the red is represented as 0, 0, 1. Or we can also remove this if you want. Okay, so we can we can do it as red as 0, 0, green as 0, 1, blue as 1, 0. So this is known as odd nominal encoding. So we use the one-hot encoding to convert the text into data or text into numeric form. This is known as ordinal encoding. I hope you get it. And after this, we will be discussing many topics like what is mean by binarization. For next, outlier detection. Next, we have like next, next, next videos. Next, what we'll be discussing. So after this, the entire feature construction is not over. Our feature transformation is not over. This is the part one, and the part two will be like outlier detection. Okay, outlier detection and imputing. Impute, what is mean by imputing? How we can impute the missing data. Next, outlier detection, outlier removal, everything. And yeah, that's it. Next, binarization and DC binarization. Sorry, binarization. Yeah, this will be the second part of the feature transformation. I hope you understood it, and I hope you subscribe and